Light-emitting diodes, LEDs, have a wide array of applications in industry. They are used as indicators in many devices, are sometimes combined to form sign displays, and can also be used as flashlights. You will use an LED from the VEX Robotics kit as an indicator to debug code or to signify that a key value has been reached. The VEX flashlight is a device with 4 white LEDs, which combine to provide a light source that is useful as an illuminating light. The LED has 2 prongs which connect to a 3-slot cable adapter. The LED can connect to the VEX Cortex directly or through an extension cable. Connect the LED to digital input and output 12 on the VEX Cortex. The VEX flashlight consists of an array of 4 LEDs that provide a variable light source depending on the supplied input voltage. When connecting the 2-prong cable to the VEX Cortex 3-pin socket, the flat side of the flashlight cable must be positioned next to the flat edge of the VEX Cortex socket. Connect the flashlight to motor output 1 on the VEX Cortex. Now let's launch the Robot C software for VEX Robotics. Once the software is loaded, you'll need to open the PLTW template file. Select Skip to bypass these instructions. Complete the appropriate template information and save the file as your last name _LED flashlight. To configure our hardware setup, select Robot. Select Motors and Sensors Setup. Select VEX Cortex Digital Sensors 1 through 12. Assign the LED to digital port 12. Label the digital port 12 as green. Next, select Motors. Assign the flashlight to port 1. Label the port as flashlight. Close the Motors and Sensors Setup window by selecting OK. And notice that the pragma statements at the beginning of the file were automatically updated. Verify that the physical setup is correct by selecting Robot. Then select Compile and Download Program. Flashlight values can be assigned between 0 and 127 to vary the brightness, where 127 is the brightest output possible. Under the Motors with PID window, change the flashlight value power to 32 and press Enter. Now change the flashlight value power to 127. The LED is shown in the Sensors window. It is treated as a sensor, so it cannot be manipulated. 0 displays if the LED is off, 1 for on. Now that we've verified our hardware configuration, let's set up our program. Recall from the program planning lesson that a program is a set of commands that tells a robot what to do and how to react to its environment. For our program, we will turn on the LED and flashlight for 10 seconds and then turn both off. So let's identify our program's task description as turn on the LED and flashlight for 10 seconds. Now let's create the program's pseudocode. We will consider complex behaviors first, then simple, and finally basic behaviors. The task description is already at the simple behavior level, so let's break the behavior down into basic statements. The behavior, turn on the LED and flashlight for 10 seconds, can be broken down with pseudocode as shown. Now let's create our program based on the pseudocode. Task main marks the beginning of any code. The VEX Cortex will execute lines of code contained within the curly braces, so enter any statements here. Expand the natural language function library. Select natural language within the text functions window. In this instance, we'll need the special libraries. Drag our first statement, turn LED on, directly under the open curly braces. Define it as green. Insert the comment, turn green LED on. Next, we need to turn on the flashlight. Drag the statement, turn flashlight on, into the next code line. Define this statement as flashlight. The flashlight brightness level is also needed. The values range from 0, off, to 127, fully on. Highlight brightness and type 127. Finally, create a comment identifying what our line of code is accomplishing. Something like flashlight on with full brightness. Next, we need to wait for 10 seconds. Natural language has two built-in wait statements shown. One is measured in seconds and the other in milliseconds. Insert a 10-second wait time by dragging the wait statement into the program directly under the flashlight command. Change the wait time to 10. Insert a comment describing the command, something like 10-second wait for LED and flashlight. The LED and flashlight will continue to be powered on at the end of the wait command unless a command is given to turn both off. Note that the end of the program will turn all devices off, but a better practice is to intentionally turn the devices off. Drag the command turn LED off into the program directly under the wait command. Define the port as green. Insert the comment, turn green LED off. Drag the command, turn flashlight off, into the program directly under the turn LED off command. Define the port as flashlight. Insert the comment, turn flashlight off. Our next step is to compile the finished program. Select Robot, then compile and download program. The test bed should now be operational as described in the program. Any program errors or warnings will be displayed in the Program Debug window, which is typically located at the bottom of the Robot C window. A red X appears on the line number of any code containing an error. The message will describe the error. A common error is a missing semicolon at the end of a line of code where one is needed. Another common cause of unexpected robot behavior is insufficient power to the Cortex. Confirm that a fully charged battery is connected to the Cortex and that it is powered on. This concludes the PLTW instructional resource on LED and flashlight commands.